Hello, geometry students. We're still in chapter 10, which focuses on circles and line segments in circles and angles in circles. In our last section, 10-6, we were focusing on angles that are in a circle, and we were looking at an outside angle. Let's quickly review this. If I have an outside angle, this is two secant lines. Here's my outside angle. To find an outside angle, you take its big arc and you minus the small arc, and then you divide by 2. The other angle relationships that we learned during section 10-6 was an inside angle. And again, this is a secant line and that is a secant line, but the angle is inside the circle. So if you have an inside angle, I'm going to abbreviate, then you're going to take the two arcs that are created by that angle, this arc here, and this is vertical, so this is the other arc. You take the arc plus the arc, and then you divide by 2. So those were our angle relationships with the arcs that they create. So now today what we're going to do is we're going to focus on line segments in the circles. So in my first example here, I have intersecting chords. And so I have this chord is intersecting that chord. And the special relationship that exists with those line segments is that you can take the two pieces of one chord, A and B are on this chord here, you can multiply them together, and it will equal the other chord's two pieces multiplied together. So I'm going to take C and D, and I'm going to multiply them together. We also have segments that intersect a circle outside of that circle. As you look at this example here, this is a secant line, and that's a secant line, and it's intersecting the circle outside. And so they have a formula here where they're taking the, see this? This is the whole entire line segment multiplied by AB. The whole entire segment multiplied by AB. And then it is equal to the other secant line, the whole entire piece, multiplied by AD. I'm not always going to have this diagram available, so what I do instead is I say you take your outside piece, AB, and multiply it by the entire piece, which is CA. And then that's going to equal, again, the same thing. This is my outside piece, which is AD, so my outside piece, and then times my entire line here, which is AE. So I am using their formula here, but I'm just using my own words is what I'm doing here, entire. So when I have two lines that are intersecting outside the circle, these are secant lines, they intersect at two places, then I'm going to use the formula, the outside piece of that line segment times the entire piece of that line segment. I'm talking about the top one, and then I'm going to set it equal to the bottom line's outside piece times the bottom line's entire. So when you look at the second example here now, you're saying, can I apply this to the same formula? When I look at this top piece, AB is the outside piece of that line, isn't it? And the entire line is also AB. And see, they have that written right here, AB squared. AB times AB is AB squared. Now I'm going to go down to my bottom line. I'm going to do my outside piece, which is AC, and I'm going to multiply it by my entire line, which is DA. So let's go down here and look. Sure enough, they have AC, and DA is the same thing as AD. So this formula here works on both of those diagrams. So when you have two segments intersecting outside of the circle, you're going to take the outside piece times the entire equals outside piece times the entire. All right, let's take a look at some of our examples. So in example number 1, I have 2 chords intersecting inside the circle. So I need to take my 2 pieces and I need to multiply them together. So I'm going to take x and x plus 12. And then I'm going to take my other 2 pieces from the other chord and multiply them together. So I'm going to get x plus 6 and x plus 2. All right, so now at this point I need to distribute and get x squared plus 12x. I need to multiply both of these binomials together. We do that by using our FOIL method. X squared, I've got my 2x and my 6x, so I'm going to write 8x down, and then plus 12. Working on my algebra, my x squares, one on each side, so they're going to cancel. Leaves me with 12x equals 8x plus 12. Get your x's together. That gives me 4x equals 12, x equals 3. Now we don't have any directions here, so I should have typed that we were looking for the value of x. So we'll be happy with that answer and we'll box it in. Be careful because maybe in your homework they may be asking you to find line segment ZS. So just be heads up on that, guys and gals. All right, let's take a look at example number 2. This time I have 2 segments that are intersecting outside of the circle. So I have 2 secant lines intersecting outside of the circle. So I'm going to use my outside times my entire. I'm going to abbreviate here because I'm going to run out of room. And then I'm going to do outside times entire again. So I'm going to look at XT first. Looking at this line segment, my outside is 7. I need my entire. Now be careful, this is what some students will do. They see this 12 and they think, okay, it's 7 times 12. You need the entire line, so you need to use 19 there, guys, 19. So now I'm going down to my bottom segment. Here, my outside piece is 6. Again, same thing. Some students will just write this x down. You need the entire line here, so that's going to be x plus 6. All right, now 7 times 19, 133. Distribute your 6, 6x plus 36. Move your 36. You're going to get 97 equals 6x. Go ahead and divide by 6. Now I don't have any directions here about rounding, so I'm just going to take 97 divided by 6, and I guess I'm going to write in a fraction form because it doesn't say anything about rounding. And I get 16 and 1/6. Okay, let's take a look at the last example, which is number 3. And so again, I have my line segments are intersecting outside of the circle. I have a secant line. This is a secant line. This is a tangent line. They're intersecting outside of the circle. So once again, I'm going to use the outside times entire. Outside times entire. So when I look at my top line here, AD, my outside piece is X. My entire would be the whole entire thing. Once again, be careful because some students are going to write X plus 4 down. I have an X and an X, so I have a 2X plus 4. When I come down to the bottom segment, the tangent line. The outside piece is 10. Also, that whole entire line is 10, so I'm going to do 10 times 10. All right, let's go ahead and distribute. I'm going to get my 2x squared plus 4x equals 100. All right, so this has a quadratic term. It has an x squared in it. So I need to get everything on one side, and then I need to factor it. So I'm going to move my 100 over. I've got 2x squared plus 4x minus 100 is 0. At this point, I'm looking at all three numbers here, and I see that 2 goes into all of those. So I'm going to factor out a 2. 2. That leaves me with an x squared. When I take a 2 out of the 4, that leaves me with a 2x. When I take a 2 out of the 100, it leaves me with minus 50 equals 0. Now, if you want to, you could go ahead and divide each side by 2. Those 2's would cancel. That'll leave you with x squared plus 2x minus 50, and 0 divided by 2 is 0. So now at this point, because we have a quadratic term, an x squared, we're going to have to factor it, reverse a FOIL. So I'm trying to think of numbers going like this, x and x. I'm thinking of numbers that multiply to get negative 50, and they have to add to get 2. Right? And I'm thinking about this. I'm thinking about 1 and 50. I'm thinking about 2 and 25. And I'm thinking about 5 and 10. None of those work, so I'm not going to be able to factor this. Maybe in your homework you're going to be able to factor sometimes, people. So try that. If you're not able to factor, then what do you have to use? Do you know what that is? You're going to have to use the quadratic equation. X equals a negative b plus or minus square root b squared minus 4ac all over 2a. So we're going to have to use our quadratic formula. Remember, your a is the coefficient in front of the quadratic term, or the x squared. Your b is the coefficient that is in front of your linear term, or your x. And then your c is your constant, or the number that's all by itself. So over here on the side, it helps me if I can write a equals 1, b equals 2, and c equals negative 50. So then now I'm going to plug those into my formula here. I'm going to take the opposite of b, which is going to be x equals a negative 2 plus or minus. Then I need my b squared, so I'm going to write 4 down right away, minus 4. I need a, which is 1, and my c, which is negative 50. And then that's all over 2 times a, which is 1. All right, so now I have x equals a negative 2 plus or minus, and I'm working on this right here, guys. Square root of 4. A minus 4 times 1 times negative 50 is going to get me a positive 200. And then that's all over 2. So now I have x equals a negative 2 plus or minus root, that's 204, all over 2. So, you know, when you are trying to factor, sometimes you get 2 answers. Same thing with the quadratic formula. You're going to possibly have 2 answers here. So at this point, I'm going to have x equals a negative 2. I'm just going to write plus square root of 204 over 2. So I'm going to go ahead and work that out. I'm going to hit negative 2 plus root 204. I'm going to hit equals on my calculator at that point. I have 12.28. I'm leaving my calculator full, and then I'm going to divide by 2. So x equals 6.1. I don't tell you what to round to. This one here, I have to round. I can't write it as a fraction because I'm getting a huge decimal. Quadratic formulas, you have decimals. Okay, so that's my first answer. Now I need to do the minus. So x equals a negative 2 minus root 204 all over 2. So same thing here now. I'm going to take my negative 2 minus my root 204. Then I'm going to hit my enter button on my calculator. I'm getting negative 16.28. I'm going to divide that by 2. X equals a negative 8.1. Now, if you were just doing an algebra problem, you would keep both of these answers. But remember our value of x. Let's go up here and look. Our value of x represents a line right here. I can't have that line be negative 8. So I'm going to go back down here to my answers. I'm not going to be able to keep this answer because that's representing a line. I'm only going to keep my 6.1. All right. Well, you guys have a great night, and I will see you in class tomorrow.